radio communications. In this video, we are going to see about radio communications. Radio communication is a popular way of transmitting information between distant places. Electromagnetic signal. Light is a form of electromagnetic wave or signal. Electromagnetic signal is oscillatory in nature. The distance between two wave crests is the wavelength of the signal. The signal traverses at the velocity of light. Analog versus digital signal. The signal can be either analog or digital. An analog signal is one in which the signal intensity varies in a smooth fashion that is continuous over time. On the contrary, a digital signal is one in which the signal intensity maintains a constant level that is discrete for some period of time and then changes to another constant level. Characteristics of electromagnetic signals. The table shows the spectrum of electromagnetic signals with common nomenclature. The signals have different characteristics and abilities for communication. The key considerations are how far the waves can go, through what these can go, and how much data these can carry. Multiple access technique. The multiple access technique is a mechanism by means of which many users can share the frequency spectrum allocated for an application. There are mainly three multiple access techniques: frequency division multiple access, that is FDMA, time division multiple access, that is TDMA, code division multiple access, that is CDMA. Operational module for radio communication. The operational modules in both the transmitter and receiver ends. At first, the analog signal is transformed into digital by the source coder. The channel coder detects and or corrects the errors due to transformation. However, all the errors cannot be corrected by the channel coder. The effect of such errors is minimized by the interleaver. Finally, the signal is given upshift of frequencies so that it can be transmitted over the radio path in an efficient manner. When the signal is received at the receiver, a reverse process is applied to extract the original signal. Modulation. The modulation translates a source or baseband message signal to a bandpass signal whose frequency content is concentrated in a narrow band at frequencies very high compared to a baseband frequency. AM. Amplitude modulation alters the amplitude of a carrier signal so that its amplitude matches with the original, that is, baseband modulating signal. ASK. The input to such a modulation process is the binary bit streams. The two binary values 1 and 0 are represented by two different amplitudes. The transformation of input bit stream 1001. FM. The frequency of the carrier signal is altered to carry the content of the modulating signal. Cellular radio. In this video, we are going to see about cellular radio. Cellular telephones use radio waves to provide two-way communication. The cell phone communicates with radio antennas, that is towers, placed within adjacent geographic areas called cells. A telephone message is transmitted to the local cell, that is antenna, by the cell phone and then is passed from cell to cell until it reaches the cell of its destination. At this final cell, the message is either transmitted to the receiving cell phone or is transferred to the public switched telephone system to be transmitted to a wireline telephone. The technology has progressed through several stages. First generation, that is 1G, cellular used analog signals and had low bandwidth, that is capacity. Second generation 2G uses digital signals primarily for voice communication. It provides data communication up to 10 kilobits per second. Third generation 3G uses digital signals and can transmit voice and data up to 384 kilobits per second when the device is moving at a walking pace, 128 kilobits per second when moving in a car, and up to 2 megabits per second when the device is in a fixed location. 3G supports video, web browsing, and instant messaging. Fourth generation, that is 4G, is still under development and does not fall under one defined technology or standard. The Wireless World Research Forum defines 4G as a network that operates on internet technology, combines this technology with other applications and technologies such as Wi-Fi and WiMAX, and operates at speeds ranging from 100 Mbps in cell phone networks to 1 Gbps in local Wi-Fi networks. Third generation cellular service does have disadvantages. Perhaps the most fundamental problem is that cellular companies in North America use two separate technologies. Verizon and Sprint use code division multiple access, that is CDMA. Singular and others use global system for mobile communications, that is GSM. In addition, 3G is relatively expensive and most carriers limit how much you can download and what the service can be used for. GSM, Group of Special Mobile. In this video, we are going to see about GSM, that is Group of Special Mobile. The Group of Special Mobile is sometimes known as Global System for Mobile and is a second generation cellular mobile standard. GSM lies under second generation systems that replaced first generation analog systems. There are three subtopics important under GSM. They are GSM architecture. In GSM architecture, the subsystems are Network and Switching Subsystem, that is NSS, Radio Subsystem, that is RSS, Operation Support Subsystem, that is OSS, Network and Switching Subsystem. The Network and Switching Subsystem, that is NSS, manages the connectivity between wireless networks and public networks. NSS contains Mobile Services Switching Center, that is MSC, Home Location Register, that is HLR, Visitor Location Register, that is VLR. radio subsystem, that is RSS. In this video, we are going to see about radio subsystem, that is RSS. In GSM architecture, the radio subsystem RSS consists of two main parts: mobile stations, base station subsystem. In a GSM network, it has many base station subsystems, that is BSS, where each one is controlled by a base station controller called BSC. The BSS unit also consists of many base transceiver stations, BTS. The base station controller can manage many BTS. It can reserve many radio frequencies, handing over functions from one base transceiver station to another base transceiver station. The subscriber identity module, termed as SIM, with all user-related information are available with mobile station MS. The International Mobile Equipment Identity, that is IMEI, is used for identifying a mobile station in the network. Few important things contained in a SIM card are identifiers, card type, serial number. Operation subsystem, OSS. In this video, we are going to see about operation subsystem, OSS. All functions related to networking operations and maintenance are done by operation subsystem. It consists of Operation and Maintenance Center, Authentication Center, that is AUC, Equipment Identity Register, that is EIR, Operation and Maintenance Center, that is OMC. The functions managed by the operation and maintenance systems are traffic monitoring, subscriber and security management including billing, status of network entities in a report form, OMC monitors and maintains each MS, BSC, BS and MSC within entire GSM system. It is also responsible for integrity and performance of each subscriber equipment within the system. Authentication Center, that is AUC. The user identification, protection of all user information are taken care of by Authentication Center. It can also be kept safe as a part of Home Location Register, that is HLR. Equipment Identify Register, that is EIR. EIR is responsible for all devices identification used in a network. Broadcast Control Channel. In this video, we are going to see about Broadcast Control Channel. It is denoted as BCCH. It is used for signal information by base transceiver station, that is BTS, to all MS in a cell. There are few important channels known as Frequency Correction Channel, that is FCCH, Synchronization Channel, that is SCH. The FCCH is used for frequency correction information by BTS. Basically, FCCH and SCH are subchannels of BCCH. The advantage of using this GSM standard is its worldwide localization of users facility. To find or locate a MS, the main features required are listed below. International Mobile Subscriber Identity, that is IMSI. Mobile Station International ISDN Number, that is MS-ISDN. Temporary Mobile Subscriber Identity, that is TMSI. Mobile Station Roaming Number, that is MSRN. Two opposite terms, mobile terminated call, that is MTC, and mobile originated call, that is MOC, work very accurately in this network. MOC suits it to an environment when a call is purely initiated, that is, when MS transmits a request signal for a new connection in the GSM network. MTC works in a situation where the calling station is outside the GSM network. The flow of messages for MTC and MOC and the GSM are unique in nature. Security in GSM. In this video, we are going to see about security in GSM. The degree of security in GSM is higher with respect to confidential information in subscriber identity module, that is SIM, and the authentication center, that is AUC. Confidentiality. To maintain confidentiality, encryption and decryption techniques are used. The information about user, that is subscriber, is encrypted. Only an authorized person can decrypt it. Encryption. All information that are user-related are encrypted. This ensures more privacy from the point of subscribers. If authentication process is over the base transceiver station and mobile station can work with proper encryption by using cipher key, say KC. The base transceiver station, that is BTS, and the mobile station, that is MS, can encrypt at one end and decrypt at the other end. For example, cipher key of 64 bits is used. Authentication. Users can opt for any type of service that a GSM network can offer. The authentication is based on the SIM card that stores user-related information. A random number Rn and the authentication key Ki along with the specific algorithm is used for developing user authentication. The access control generates a random number Rn and the SIM provides a signed response where Authentication Center AUC does the basic generation of random values, random number Rn, signed response, and secret key KC. Ultimately, this is sent to Home Location Register, that is HLR. The Visitor Location Register, that is VLR, sends random number Rn to the SIM, where the subscriber and network does the same type of functions. CDMA telephone system. In this video, we are going to see about CDMA telephone system. Mobile telephony using CDMA technology is very similar to the mobile telephony using GSM technology. It also uses the cellular architecture, base station, NTSO, etc. The only major difference is the modulation method used to modulate subscribers' voice signals. In the DSSS modulation scheme used in CDMA mobile telephone system, K is around 128. Thus, 2k minus 1 is a very large number, nearly equal to 1040. Therefore, the number of orthogonal chip sequences Q which are assigned to telephone subscribers from this huge set of chip sequences is quite large, around 1 million. CDMA mobile telephony works as follows. As in GSM, one frequency band is picked for BS to mobile communication and another for mobile to BS communication. The frequency band is in the 900 MHz band. The value of Q used to spread the code at the BS is used by the handset to decode the spread spectrum to recover the original message. The entire spectrum is available for each telephone subscriber. In practice, it is similar to that of GSM. CDMA can also support many more users in a cell compared to GSM. CDMA also provides SMS, however GPRS is not available in CDMA. Satellite networks, that is VSAT. In this video, we are going to see about satellite networks, that is VSAT. Satellite network is a combination of nodes that provides communication from one point on the Earth to another. A node in the network can be a satellite, an Earth station, or an end-user terminal or telephone. Orbits. An artificial satellite needs to have an orbit, the path in which it travels around the Earth. The orbit can be equatorial, inclined, or polar. Footprint. Satellites process microwaves with bidirectional antennas, that is line of sight. Therefore, the signal from a satellite is normally aimed at a specific area called the footprint. The signal power at the center of the footprint is maximum. The power decreases as we move from the footprint center. The boundary of the footprint is the location where the power reaches a predefined threshold. Three categories of satellites. Based on the location of orbit, satellites can be divided into three categories: GEO, LEO, MEO. GEO satellites. Line of sight propagation requires that the sending and receiving antennas be locked onto each other's location at all times. One antenna must have the other in sight. For this reason, a satellite that moves faster or slower than the Earth's rotation is useful for short periods of time. To ensure constant communication, the satellite must move at the same speed as the Earth so that it seems to remain fixed above a certain point. Such satellites are called geosynchronous. MEO satellites. Medium Earth orbit, that is MEO satellites, are positioned between the two Van Allen belts. A satellite at this orbit takes approximately 6 hours to circle the Earth. GPS. One example of a MEO satellite system is the Global Positioning System, that is GPS, orbiting at an altitude about 18,000 km, that is 11,000 miles above the Earth. GPS is based on a principle called triangulation. LEO satellites. Low Earth orbit, that is LEO satellites, have polar bits. The altitude is between 500 to 2000 km with a rotation period of 90 to 120 minutes. The satellite has a speed of 20,000 to 25,000 km per hour. An LEO system usually has a cellular system of access similar to the cellular telephone system. The footprint normally has a diameter of 8,000 km. Because LEO satellites are close to the Earth, the round-trip time propagation delay is normally less than 20 milliseconds, which is acceptable for audio communication. Iridium system. The original name iridium came from the name of the 77th chemical element. A more appropriate name is dysprosium, the name of element 66. Iridium has gone through rough times. The system was halted in 1999 due to financial problems. It was sold and restarted in 2001 under new ownership. Global Star. Global Star is another LEO satellite system. The system uses 48 satellites in 6 polar orbits, with each orbit hosting 8 satellites. The orbits are located at an altitude of almost 1,400 kilometers. Teledesic. Teledesic is a system of satellites that provides the fiber optic-like broadband channels, low error rate, and low delay communication. Its main purpose is to provide broadband internet access for users all over the world. It is sometimes called Internet in the Sky. Mobile Adhoc Networks, MANET. In this video, we are going to see about Mobile Adhoc Networks, that is MANET. In this video, we are going to see about Mobile Adhoc Networks, that is MANET. The Mobile Adhoc Networks, MANETs, have many advantages, and one of the most important advantage is its infrastructure independent nature. The ad hoc networks does not need infrastructures that is required for other wireless networks. The ad hoc networks are composed of the equal nodes that can communicate with each other through wireless links. There is no central control for their work. A MANET network is composed of mobile, autonomous, wireless nodes that could be connected at network edges to that of the fixed wired internet. Salient features of MANET includes network size. It refers to the geographical coverage area that could be covered by the network. Connectivity. It refers to many issues. One such is the number of neighboring nodes that could link to them directly. This link may be bidirectional. Connectivity also refers to link capacity between any two nodes. Network topology. The user mobility can affect the network topology. Due to it, the network protocols has to adapt to topology changes. User traffic. The design of MANET is thick related with user traffic. Operational environment. It refers to terrain, whether it is urban, rural, or maritime, etc. Energy. In MANET, there is no availability of fixed base stations. If some nodes are not participating in network operations, shutting them for some time can be done. Example for MANET. An example of MANET connected to Internet is shown above. Individual nodes transmits and receives data with globalized Internet arrangement. A simple ad hoc network composed of nodes and the complexity involved with network setup are shown in following diagram. The mobile router 1 and mobile devices 2 forms MANET as shown here. Its relation with fixed network is established.